Hello everyone, welcome back to my channel. In this video, we'll be solving another important DSA question important for FAANG and top tier companies. So today's problem is best time to buy and sell stock, which is a Leetcode question. This problem has several variants. We'll be covering other variants in upcoming videos. In this video, we'll be solving it with one pass method. So without wasting much time, let's jump in to see the question and then we'll try to develop some intuition for it. So this is the question number 121 on Leetcode. You're given an array prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. So return the maximum profit you can achieve from this transaction. If you can't achieve any profit, return 0. So let's understand this with one of its example. So this is the prices array. These values represent price of a stock on a particular day. Based on the explanation given below, on day 1 it is 7, on day 2 it is 2. If someone buys at day 1 and sell it at day 2, he will have a loss of 6, which is not our answer. We have to return the maximum profit by doing one transaction in this array. So the maximum profit that we can get is by buying on day 2 and selling it on day 5. When price is 6, it will give us a profit of 5, which is our answer. One more note has been given below that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell it. That is quite obvious. Let's consider another array. Here, getting a profit is not possible because you can see the prices are just falling. Therefore, we'll be returning 0. So this is the entire question. Now let's try to develop some intuition to solve this problem. So in order to solve it in the most efficient way, we need to solve it in one pass, in one traversal of for loop, so that it can have a time complexity of big O of n. So how we'll be doing it? Let's see. For this, I'll be taking help of two variables. First one is min price. I'll be first initializing with integer.max value, and its purpose in life is to store the minimum price encountered till a particular point while traversing the array. And another variable that I'll be taking is max profit. This is the variable which will be storing my answer. I'll be initializing it with 0. So in short, you can say that the min price variable is for tracking the lowest price seen so far while traversing this array. And the variable max profit will be used to store the best profit achievable up to the current date. Let's see the implementation of this logic with the help of a table. I'll be using this array as well as these two variables. I'll be fetching value one by one from the array. That's why I have written it as price, not prices. So on the first element 7, I'll observe that the min price, which is the maximum integer value, is greater than 7. So I'll be assigning min price the value 7 and the max profit would remain 0 because it will get updated in the else statement. Now taking the second value, my min price would go down to 1 and the max profit would remain 0. On the third iteration, my current value would become 5. Min price will not get updated because 5 is greater than 1. So the min price updation condition would become false. Now we'll be updating our max profit, which is the current price minus the min price. I'll get a profit of 4. Again, the fourth iteration, I'm getting 3. This condition is not satisfied because 3 is greater than 1. 3 minus 1 equals 2. So the max profit value would remain as it is. On fourth iteration, I have 6 in my hand as my current value. I'll be checking it with min price. Min price would remain as 1. 6 minus 1 equals 5, which is greater than 4. So it means my maximum profit has increased by 1 and it is now 5. Now taking the last element, it is again also not less than 1. It is again also not less than 1. So 1 will remain as it is in min price. 4 minus 1 equals 3, which is less than 5. So it won't bother max profit variable and it will remain as it is. So the final answer that I'll get for max profit would be 5. Let's now implement our logic in the form of code. First of all, I'll be declaring the min price variable and initializing it with integer.max value. Next, max profit variable. Now I'll traverse the array, fetching each element one by one. The first condition, if my current price is less than the min price, I'll update my min price. Meaning if my min price is more, then my current element, then update the min price to the current price. Else if, else if I'll check, am I getting a profit which is greater than my max profit, my current max profit value? For this, price minus min price greater than max profit. If this condition is satisfied, meaning I can get a value which is greater than max profit. Now, in the end, I'll be simply returning my answer, which I have stored in max profit variable. Let's now check the output of our code, whether it is running fine or not. Yes, it is, and it is highly optimal. So the time complexity would be big O of n, and space complexity would be big O of 1. So this is the entire explanation for our question. If you have any doubt, you can comment down in the comment section. Thanks for watching. See you in the next video.